Hey everyone, I'm Eddie Does Math. Welcome to my channel. Here are the hardest questions in Algebra 1. Quadratic equations are one of the toughest topics in Algebra 1, especially when we learn about the quadratic formula. In this case, we aren't able to factor nicely with integers, so that's how we know we have to solve using the quadratic formula. And you can remember it with this little song. It goes negative b plus or minus the square root of b squared minus 4ac all over 2a. As silly as it may seem, it does help a lot of students remember this. So x equals negative b is negative 7, negative of that will be positive 7, plus or minus the square root of b squared, that's 49, minus 4 times ac, that's negative 15, all over 2 times a, which is 5. So we have 7 plus or minus 49 plus 60 is 109, all over 10. There are your two values of x, and we'll write x here as well. Next, systems of equations, not just linear, but nonlinear is where students tend to struggle. Now, for this one, substitution is key. Identifying that we can substitute here is our very first step. 2x plus x squared minus 4x minus 1 is equal to 7. Since we have a quadratic equation, let's set everything equal to 0, meaning move everything to the left side since our leading coefficient is already positive. We have x squared minus 2x minus 8 is equal to 0. Now, think of two numbers that multiply to negative 8 and add up to negative 2. Well, those two numbers are negative 4 and positive 2. Keep in mind that whenever we have a product of two expressions equal to 0, then either one of those expressions can be set equal to 0. So if x is equal to 4 and x is equal to negative 2. Knowing these two x values, we're not done, since a solution to a system of equations turn out to be coordinate points, and coordinate points include both an x value and a y value. So we can solve for those y values by plugging it in back into the second equation. We get y is equal to 7 minus 2x. Let's plug each of these x values in. We get y is equal to 7 minus 2 times 4, and that's equivalent to negative 1. When we plug in the negative 2, we get y is equal to 7 minus 2 times negative 2. That's plus 4 equals 11. So our two solutions to the system of equations are 4 comma negative 1 and negative 2 comma 11. And those are points of intersection of this parabola with this line. Rational equations. These aren't that difficult, but they look more intimidating than they are. Let's take a look. So we have 6 over x minus 3 plus 8 over x plus 1, and this is equal to 5x plus 1 all over both of those denominators multiplied. So in order to get that same denominator, a common denominator, I can multiply x minus 3 times x plus 1 on the bottom. Whatever I do to the bottom, I must do to the top. Same idea here. I'm going to multiply by x minus 3, x minus 3. Now, our new equation then is 6 times x plus 1 plus 8 times x minus 3, and all of this will be equal to 5x plus 1. Now, you may be wondering, wait, where did the denominators go, Eddie? Well, x minus 3 times x plus 1, x minus 3 times x plus 1, those are common denominators. They'll come together, and notice on the right, we have that same exact thing, which means since we have common denominators on both sides of the equality, the numerators must be equal. And that's why we set the two numerators equal to each other. And now let's distribute and solve for x. Make sure you distribute properly and completely. We have 6x plus 8x, that's 14x, minus this 5x is 9x. 6 minus 24 is negative 18. Add 18 to both sides, I get 18 plus 1, which is 19. And my final answer for x will be 19 over 9. Radical equations. Now, these aren't too difficult, but I'll show you why students struggle with this one in a little bit. In order to get rid of a square root, we must square both sides. Now, one kind of step that students struggle with here is getting this correct. Students forget that x minus 2 squared means x minus 2 times x minus 2. You cannot forget that middle term, right? X squared minus 4x plus 4. A lot of you would probably write x squared plus 4 straight from this, or even x squared minus 4. You cannot forget that middle term. Now, since this is a quadratic equation, let's move everything to one side. And since our leading coefficient is positive on the right side of the equality, I'm going to leave everything on the right side of the equality. Get x squared minus 5x. 4 and 4 eliminate, leaving us with x times x minus 5. So x can equal 0, or x minus 5 will equal 0. Therefore, x can equal 0 or 5. But with radical equations, you must check your answers. So we plug in x equals 0. Let's check. That means the square root of 0 plus 4 needs to equal 0 minus 2. Does the square root of 4 equal negative 2? No. So x equals 0 does not work. Now let's try x equals 5. And this is why it's important to check our answers. Plug in x equals 5. We get radical 9 is equal to 3. The square root of 9 is 3. Boom. X equals 5 is our only answer to this radical equation. Last but not least, word problems. This word problem is actually very, very simple. It's one that I even show in pre-algebra. However, getting it in equation form, I noticed that students find a very tough time with that. So that's why I chose this one. Let's take a look. Henry is leaving town on a bicycle traveling at 12 miles per hour. 1 hour later, Violet follows the same road traveling at 16 miles per hour. How long will it take for Violet to catch up to Henry? We know for sure, for a fact, that Violet will end up catching up to Henry because Violet is traveling at a faster speed than Henry is. But now setting up the equation is where students struggle, and let me help you with that. Henry is leaving town on a bicycle traveling at 12 miles per hour. So every hour, Henry will be going 12 miles. We want to know how long it will take, so x will be the number of hours. Now, 1 hour later, Violet follows the same road, traveling 16 miles per hour. But now, this number of hours needs to be the same, but Henry started first. So how do we justify that we're using x on both sides? Well, we say 1 hour later, after Henry has left town, he will have traveled 12 miles, and that's how we solve this. Coming up with that might be a little difficult. Some students just create a table and just find when the numbers equal each other. That's a huge waste of time. Why not just create an equation that we can solve very easily? Subtract 12x on both sides, and x will equal 3. So 3 hours is how long it will take Violet to catch up to Henry.
If you enjoyed this, found it useful, or just learned something new, make sure to subscribe and check out the description below for links to my courses. See you soon.